Hello. When I ask the question to students, what is pi? The answer I receive usually is 22 by 7, 3.14 or the third option. But is that correct? No. None of them are right. If we actually have a value to represent pi, we would have used that value itself. We will not be requiring pi at all. So 22 by 7 is not pi, 3.14 is not pi, and the third option is also not pi. So what exactly is pi? Let's explore in this video. Take the example of a square. In a square we have two sides. Now the diagonal is s root 2. We can apply Pythagoras theorem and get the diagonal value as root 2a. The perimeter of a square is 4a. Now if we find the ratio of perimeter to diagonal, the value we get is 4a by root 2a. So a get cancelled, so it's root 2. So if we substitute the value, we are getting a value which is close to 2.8. Okay. Now in this, irrespective of the size of the square, be it a small square or a large square, the value remains same. The ratio of perimeter to diameter remains same. Okay, so it doesn't, let's say I have a 3 cross 3 square or I have a 30 cross 30 square, this ratio remains same. It's very important. Now let's move on to the next figure, hexagon. In a hexagon, the diagonal length is 2a. Quick, how do we find it? Because all the triangles are equatorial triangles, because this angle is 60 degrees. No, the total angle of the center is 360. So if we divide it by 60, we get 360 by 60. 360 by 6, each angle is 60, and these two are also equal. So these two angles are also equal, so the value will be 60, 60, 60. So if this side is a, this length also will be a, so both are a, so the diagonal length is 2a. So perimeter by diagonal in the case of a hexagon, be it a small hexagon or large hexagon, the value remains same, which is 3. Now moving on to an octagon has 8 sides. So the center has total of 360 degrees, and each side is for 45 degrees. So since it's an isosceles triangle, we are making it into a right angle triangle, and the angle B is 90 degrees in this triangle. So this angle is, this angle is 90 degrees, and now since the total angle is 45, this half partial angle here at the center is 22.5. So applying sine 22.5, so opposite is AB, and adjacent is OA. Now the ratio will be AB by OA. So OA value will be A by 2 into sine 22.5, because 2 will come to the denominator, and OA if goes to that side, you will get the value. Now the diagonal of this octagon is twice that of OA, so we get A by sine 22.5. Now the perimeter of this figure is 8a, because the total is 8, it has 8 sides. Now the ratio of perimeter to diagonal will be 8a sine 22.5 divided by a, so a will get cancelled, we get the value which is 3.06. It gets interesting, right? Now let's move on to a decagon. A decagon has 10 sides, so obviously we have seen that each angle is 10, each angle is 36, and half of that will be 18, so same as that. In the right angle triangle, we have sine of 18 is equal to opposite by hypotenuse, which is a by 2 divided by L. And the length L value is equal to a by 2 sine 18. Now the diagonal obviously is 2L, so we get the value as a by 2L, a by sine 18. Now the perimeter of this figure is 10a, because again which has 10 sides. Now the value is p by d. The ratio of perimeter by diagonal will be 10a by a by sine 18, which is 10 sine 18, right? So again the answer is interesting, it's 3.09. Now moving on to a hectagon. Hectagon has 100 sides. So you can see how it looks like. I'm not telling, like very familiar too. Now each angle here is 3.6 because there are a total of 100. So each angle is 3.6. The diagonal will be a by. So just repeat whatever we have learned earlier. So the diagonal value will be a by sine 1.8. Perimeter is 100a. The ratio of perimeter by diagonal, the a gets cancelled. It's 100 sine 1.8. Now if it's 1000 sides, it's simply 1000 sine 0.18, and it goes on, right? So now you can use a scientific calculator to find the value. You can even use Google. You just can enter 100 sine 1.8 in Google. Now the value which we get is 3.14. Now if we are making this into a general formula for an n-sided figure, okay, what we did is for a 100-sided figure. So if we do for a n-sided figure, then the p by d value is n sine 360 by 2n. Just you do this, assume it as n, and it's 360 divided by n. Again we have to divide the value by 2. So we get the formula. So we get n sine 180 divided by n. Okay. Now the interesting aspect here in this about this general formula is if we substitute very large values, say 1000 or 10,000, just you can substitute on your own, the value will be close to 3.14. Okay. Now what is a circle? A circle is a polygon. You can assume it as a polygon which has infinite sides. Okay. When n approaches infinity, then that becomes a circle, right? So we'll call the perimeter as circumference, and we'll call the diagonal as diameter. So this ratio value, irrespective of, see in earlier figures what we saw, irrespective of the size of the hectagon, the value is 3.141, right? Now so in this the value will be circumference by diameter irrespective of the size of the circle, be it a small circle or a large circle. The ratio will be pi. Okay. Now we know the circumference is c. Let's take the circumference as c, and diagonal value obviously is twice the radius, so it's 2r. So this ratio c by 2r is nothing but pi, correct? Now what do we get for the value of circumference? Take this 2r to the other side. So what do we get? We get the circumference as 2 pi r, correct? So this is how we get the circumference of a circle. So the very formula is derived from the definition of pi. So the definition of pi is circumference by diameter. So we don't have a, because it's an infinite sided figure, we don't have a. So another interesting fact is this pi day. We know what is pi day. Pi day is 14th of March, and this pi day we have figured out the value of pi to 31.4 trillion digits. So we don't know the exact value because it's an irrational number. Pi is an irrational number, meaning we actually cannot express pi in the form of p by q, where q is not equal to 0. So the value which we use, 22 by 7 or 3.14, is just an approximation for practical purposes. Considering, so how do we define or how do we derive the formula for area of circle? Now you have a circle, okay. So what we have found out, the total circumference of the circle is 2 pi r, okay. Now the outermost circle, so the outermost circle, just cut it and extend it, you will get the base, okay. So let me repeat, the outermost circle what we have here, the total length is 2 pi r, just cut it at the top and just open it, and it as if we cut a jackfruit, like outermost layer, cut and make it, it will be forming the base of that. Then on, the radius will keep on reducing, will keep on reducing. So we'll get smaller and smaller length. So somewhere here, this circle, what we will get is up to this length, okay. So similarly, take a very small circle, we'll get this length, okay. So as we progress down, the size of the circumference will reduce, so it will actually eventually form a triangle. So basically we have converted this circle into a triangle just by cutting it at the top and forming a triangle. Now the area of this triangle, how do we calculate? Area of triangle is half into base. So the base value we know is 2 pi r, the height is r, so the formula of area of the circle is pi r. So that's how we get the area of the circle. So just to sum up, how do we arrive at it? So first we considered smaller polygons, and finally we considered circle as an infinite sided polygon. And then for a circle, pi is what? Ratio of circumference to diagonal is pi, and we also derived area formula using this approach. Now there are other interesting connections between pi. So in the earlier general formula we found the value as 180, right? Now what is it? There is a connection between 180 and pi, because when we are in 11th grade, we at times we use pi as 22/7, and at times we use the value as 180. When we express pi in degrees, so there is a connection between degree radian, 180 and pi. We will see that in our upcoming video. And also there is a connection between pi and trigonometry. So circle, obviously there is a connection between trigonometry and circles. So trigonometry is not just about right angle triangles, it's also about circles. We can see that, and what is the connection between pi and trigonometry in an upcoming video. And very, very important application of this, what we have just seen, what we did, we just approximated a circle as an infinite sided polygon, right? So one side we took it as a very small, we approximated the curve as a straight line, right? So that's a very important application which we will be using in calculus. So all these three will be seeing in the upcoming videos. Thank you.